Good morning, great viewers. I want to talk about vector resolution. Vector resolution. First of all, you need to know what vector is. Vector is defined as the quantity that possesses both magnitude and direction. Take that again. Vector quantity has to do with the quantity that possesses both magnitude and direction. Now, having said that, let us see how the number of forces acting at a particular plane can result into a singular force. The number of forces acting at a particular plane can result into a singular force. Okay, with that, we need to know what the resultant force is. What is resultant force? A resultant force is that singular force that has the same effect as the combination of other forces. Resultant force is that singular force that has the same effect as the combination of other forces. Now, in order to resolve vector effectively, there are cases you need to consider. Now, the first case here is when two forces are acting in the same direction. That's case 1. We can use diagram to illustrate that. So in this case, we have this diagram, which is F2. Then we have the second diagram, which is labeled as F2. You can see that these two forces are acting in the same direction. These two forces are acting in the same direction. Of course, how do you resolve it? Now, the resolution of these two forces can be denoted, of course, R stands for the resultant force. So if the R stands for the resultant force, of course, your F1 is the initial force, and then the second vector is regarded as the second. Of course, your resultant force will not be, if, for example, the first force is 2 Newton, and the third and the second force is 5 Newton. Of course, the resolution of these two forces will be, of course, 2 Newton to what? 5 Newton. Thus, your resultant force will not be 7. Now, this is a case of two forces acting in the same direction. Now, we want to consider the second case. In the second case, we have two forces acting in opposite direction to each other. In that case, we also use a diagram to illustrate that. This force can be 7 Newton, this is 5. Now, these two forces are acting in an opposite direction to each other. Now, how do you find the resultant of these two forces? Of course, again, we do our R equals to F2 or F1 minus F2. So your resultant force will be 7 Newton minus 5 Newton. Of course, your R becomes 2. So when you resolve these two forces that are acting in an opposite direction to each other, you are going to arrive at 2 Newton. So now we refer to that as case 2. That is case 2. Then we have case 3. In case 3, we consider two forces acting perpendicular to each other. That is, we look at the initial force, which is perpendicular, acting in perpendicular direction, and the second force acting in horizontal direction. So we can title the vertical force as R1 and the horizontal force as R2. Here we seek to know what will be the resultant force when these two forces are resolved together. And of course, you know that a diagonal is to be drawn. This diagonal represents the resultant of So we title the resultant force with the out. So if you find yourself in this case, this kind of case, all you just need to do is to apply the Pythagoras theorem to find the resultant force. You need to apply Pythagoras theorem to obtain the resultant force. Of course, you know what Pythagoras theorem is, which is the square of the hypotenuse, r squared, is equal to the square of the two adjacent sides, which is your f1 squared f2 squared. For example, if f1 is 5 Newton and f2 is 3 Newton, of course, the resultant force will be 5 squared plus 3 squared. In which case, we arrive at 5 minus 9, which is 4. And of course, our r is only square root of 34. So that will give you the resultant force. Then sometimes we also seek to know the angle that is in between the two forces. Of course, in which case we also use tan theta. Tan theta is, of course, this tan theta is 2 hour is opposite all over adjacent. Opposite all over adjacent. Opposite all over adjacent. Here, our opposite is 5, and our adjacent is 3. So that will give you the direction of the two vectors. Give you the direction of the two vectors. Now we consider the fourth case. In the fourth case, you apply the parallelogram law. Of course, you know what the parallelogram law is.